without further ado, we'd like to present STÖK up on the stage. Warm welcome.
Yay! Awesome. Wow, it's a pretty decent feeling to know that I'm the bridge between a great conference day and beer. So it's not a bad thing to do. If any of you are interested in seeing some shenanigans in terminals and shit, get in here. Okay, we're good. Time's up. We're going to start. But before that, I'm just going to reset my stuff and see how things goes. Whoop. Do that again. Here we go. Okay. Hi, my name is Fredrik Alexandersson, but most people probably know me by my hacker handle STÖK. And this is my talk, Weaponizing plaintext ANSI escape sequences as a forensic nightmare. And before doing this talk at Black Hat and at DEF CON, I was told that it was really important to have a table of contents so people would know what we're going to talk about. But we don't really have time for that because we got 296 slides to go through in 40 minutes. So let's just dig into this wonderful bug class that has been dormant for about 20 years and see what came out of that research. I used to travel the world and create all these YouTube videos over at YouTube, educational stuff, but now I'm fighting cybercrime over at TrueSec. And I've been doing a lot of incident response and stuff, and I realized that a very important thing to create a timeline is to have log files, because you kind of need to identify what happened. And I figured since I kind of like log files, maybe some other people like that too. So I figured, why not just ask shitloads of questions to the internet and see what they think about it? And I got a really good amount of answers coming back from the platform formerly known as Twitter. And the short answer is yes. Logs are important because they are a vital component for maintaining application reliability, performance, and security. But there's also this idea that logs don't lie, but people do. And even though maybe your log files isn't lying to you, do you trust them? And what happens if you don't? So let's imagine for a second that you are now the incident response lead for a global logistics company. It's 4 o'clock in the morning and you're sound asleep in your bed, dreaming about boats or containers, if you're into that, like Docker stuff. When you get this rude awakening from your manager that's pissed because you got breached, and since you are the IR team lead, you need to wake people up. So you start doing that, calling all the incident response people in, and you send them off doing the things that they are really, really good at, which is collecting all the logs from everywhere so you can create the cool timeline. But since you're a manager, you don't do grunt work. So you log into your big data app 4000 and decide to select the date range and then you export the data because you are a mature organization and you log shipped all your stuff to somewhere else. And just make sure you're downloading that into a local file called, everything. And to verify that there's actually some data in there, you're opening up cat locally and you're going through the file. And everything is all good to this stage when you suddenly, out of nowhere, gets this really nice ransomware restore ad inside your log file. And to even make it easier for you to calculate the price, they popping a calculator for you. And kind of this situation where you're starting to realize that, shit. And the reason why this is even working is thankful to ANSI escape sequences. And what put me on this track is this CVE here that I found in RAC, right? And I'm just going to read this straight out for you. It says that the effective version of these packets are vulnerable to arbitrary code injection. there's a possible shell escape sequence injection vulnerability in racks, lint, and common logger components. Carefully crafted requests can cause shell escape sequences to be written to the terminal's rack, lint, middleware, and common logger middleware. These escape sequences can be leveraged to possibly execute commands inside the victim's terminal.
Excuse me, tiny STÖK.
Yep.
What do you mean possibly? Either you can or you cannot run arbitrary commands, right?
Well, thank you, Giant STÖK, for pitching in and helping out. But yes, you're right. But it kind of depends on the terminal, because we got shitloads of different terminals that we use every day. It's everything from VS Code and Docker that have, or even Cursor that has a terminal included. Then we have iTerm and Kitty, which are more like third-party solutions to fix problems, because terminal app is not that really good, and no VT doesn't really do anything. And then we got Windows Terminal that's shipped with Windows operating system, and then we got just old stuff like Xterm. But it doesn't stop there, because most of us use terminals every day without even knowing it, because we're interacting with infrastructure or hosts inside cloud environments. We want to connect to it and manage it. And some of those frameworks are Xterm.js, which is used all over by shitloads of people because it's a node thing. And I wasn't really interested in the possibly execute commands part in the victim terminal. I want to pop shells. So I figured, like, okay, where do I even start with this? So I did the thing that every any kind of security researcher with a little bit of self-awareness do. I Googled what are ANSI escape sequences, because I had no idea. And I realized that these are the things that make my terminal look all pretty. And people apparently like to make their terminal look pretty, especially if you're into ARC and stuff and hackers shit. Then you want to have all these customizations. But even though that was a cool thing, I also realized that in 1978, the Gillstrand boys dropped their banger album, We're Gonna Have Some Fun Tonight. And even though it was released the same year, the VT100, and connecting the VT100 using serial cables to a VAX solution wasn't probably what those guys thought would be a great time, even though I probably would think that's a pretty badass thing to do. So, I mean, imagine this setup. So I figured that, okay, all these ANSI escape sequences, you could actually use those to move a cursor around or remap the keys on the keyboard, or even, print stuff like ping. But you can also use it to do this, because all of this is ANSI escape sequences telling your terminal what shit should be, what color and what placement and whatever. So you can use those in this pretty vast, kind of deep documentation that's over at the Xterm man page. And it's really, really deep, and it's really hard to understand. But I know you're all super smart. I'm not really that smart, so it took me a while to learn that. So I figured I'd just give you the basics right now, how that works. Because if you're looking into this, you'll see this. It starts with something, something, PM, character attribute, something, and yeah, what it actually is this. So it says printf, then it's some kind of hello, then we have this escape sequence and something, and that's just going to turn whatever text you put out to be green. And the reason why this even works is thanks to this escape sequence here, the escape character, \033. But escape characters, the reason why they didn't write that out is because it's an invisible character, and it comes in many shapes and form. Everything from octal, hex, Unicode, decimal, and ASCII. And I didn't really know why they did that, but I was starting to look into documentation, and different people use it in different ways. And the reason I could figure out is that Bash likes octal, Python likes hex, Java and JavaScript likes Unicode, and PowerShell likes decimal. I don't know why, but that's how it is. So if we break this down, we'll have always to start with an escape character. Then we're going to have a control sequence introducer character that tells you whatever's going to happen next. Then we have a parameter. The parameter is, in this case, 32, which is the color green. M is meaning the output, that wherever gets into the string gets put on the screen. Then it gets terminated by another escape character. 0, we got the CSI character again, then we got 0M to reset it back to whatever default color you had. And then we're closing it off with something called a bell character. And if you, like me, ever accidentally grepped any kind of like, I don't know, some kind of binary file, and your terminal starts to go like ding, 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 that's the reason why this is getting interpreted inside your terminal. So that's interesting. And I figured that, okay, that's cool. I can actually create this as green. That's nice. But, I mean, if you have this here, and I will send that into, let's say, a log file. If you were interacting with it with Vim, it's going to look like this. You will see the direct representation of the escape sequence. That's the one there in the beginning, like this is it. Same goes for Nano, if you're using that, cool for you. And then eventually, if you use that in a browser, it's going to be interpreted differently. Because here, now we have Unicode instead being played out, but as the character that explains what it is. But if you cat it, it's going to go and show you color. If you grep it, tail or even awk it, it's going to show the color. And I kind of realized that, oh, I wonder what happens if I'm running curl through this website and I put that in the title, and I got these nice explosions and colors. I'm like, this could actually be interesting. It's interpreting it and just turning things inside my terminal. Fun. So I figured that, I wonder, where can I put this on any place that would be destructive? Obviously, I thought about DNS, because DNS is the root of all evil, and it always breaks. So why not try to put it there? But the thing is that, you can see it here, it's beautifully escaped. It's perfect. You can see the double slash on the Unicode, /001B. And that's on OS X using NSLOOKUP on my normal computer. But on Windows, it renders. So it's getting interpreted differently depending on what kind of operating system and what kind of terminal you're using. So I'm like, this is really cool. But is this even a security issue? Because changing colors on your screen and doing things locally feels kind of like this self-XXS kind of thing. It's not that sexy. So I needed to figure out, as the attacker I am, where would this be an issue? Who would this be an issue for? And how would this be an issue? And what would be the consequences of that? And so I figured that it did say in the CV that it was a carefully crafted escape inside lint and common logger. So, hey, who uses those? DevOps, sysadmins, and IRM forensic people. Obviously a good target. Or more or less anyone that decides to interact with log files using a terminal. So if you're downloading this CSV file and you want to sort that in a certain way, big chance that it's going to smash you if someone tainted that one. And I figured, like the scientist I am, I better just follow the framework. So OWASP has this explanation on what defines a log injection. And a log injection is when some kind of data enters the application from an untrusted source and data is written to the application system log file. And I needed to modify it a bit because it's written and based upon doing like web attacks. So instead of saying the injection of an XXS or something, I changed it. So injection of the escape sequence, hoping that the malicious log event is viewed inside the terminal emulator. That was something I needed to check. And I wanted to make sure that the injection of commands that a terminal emulator eventually would execute. And I pondered a bit and didn't really know where would I begin, but I figured that one of the best tools that actually would be a good test bed for this would be Docker Desktop, because Docker really loves to put things on standard out. And it has this really nifty, easy app that just came with it, and it's very easy to just getting started. And the way that you interact with log files in Docker is using either Docker attach, or you'll use Docker logs follow, and you'll get whatever output getting displayed inside your terminal. Obviously, I couldn't just take my string and put it in the browser, so I needed to URL encode it. Next step was for me to just put that in there, and I think a curl is a good way to do that. I didn't have any real expectations, so I just smashed that one away, and what happened is that I didn't get any response back. it's empty. Nothing inside my curl could show me an indication that something actually happened. But if you look up here, a new line has been entered, and there's a color output inside my Docker desktop application. And that is because it's a tool that automatically just runs a terminal in the display coming out. So on the first try, I more or less had all the checkbox done. And that was really, really exciting. So even though I hear you saying like, yeah, but colors though. Remember, we can create this. This is the thing we can create by using ANSI escape sequences. And we are actually able to show that an injection can happen using inside the terminal. But like I said, the color is cool, but the Gillstrand boys, I weren't too impressed. So, and I needed to provide more impact, like changing color in a log file, yeah, YOLO. So I started to dig in a bit, and then I realized this research from H.D. Moore in 2003, where he found this really cool way to store things inside the title of the terminal. And that's cool and all. And you can see here, I'm just putting that in, boom, and it says owned inside the terminal on Windows using PowerShell. But what H.D. Moore back then found is that it was a CSI sequence, a control sequence, that could actually report back the contents of the title to the command line. And now it's starting to get really, really interesting, because what that would do is to write whatever thing that you stored inside the title and just put it inside the command line. So if somebody decided to press enter, you would have a shell. But that's fixed since 2003. So I'm like, man, that sucks. I started digging some more, and I found this really cool research by Evil Alive, Jekyll, and ASCII. And those guys had the same kind of approach, and their write-up is really cool when they just found all these vulnerabilities in all these different kind of web providing applications. So I'm like, that's cool too. But they use the same kind of title thing, which is fixed, so that was pretty boring too. But lo and behold, Ebitar Gersey did a research on ways that he can create the denial of service attack by using this. Oh no, it was the same thing, and that was fixed too. So it's like epic failure on anything that has to do with writing and reading from the title screen. So I figured that that guy that sent in the original CV, after all this research, I figured that why. At least I have to ask, what did you do? What kind of arbitrary command injection did you create that was so awesome that it gave it a CV 9.8? Or CVS 9.8. I'm like, And the answer I got back is that he didn't do it. He just referenced this write-up from 2010, and that was good enough for them. And as we know, that's been fixed. So I was kind of stuck with this whole thing that everything I had that I wanted to do and create impact was old stuff. And speaking of old stuff, this is what I looked like in the 80s. No, I'm not really, I'm joking around. This is more the badass that I was back then. But I want you to put some extra attention to the angle of the arm here, because that's exactly the same angle as this gentleman has in this band photo from the late 60s. And what's really interesting is that this gentleman down here, he's not only one of the first people that used to resell and get Unix system into Sweden, he's also my dad. So he made sure that, I had access to computers at a really early stage. I'm very, very grateful for that. Thank you, Dad. But standing here and looking at it, I'm starting to realize that I'm actually looking a bit more like Lasse, that was on the same tour as my dad when he met my mom. Oops. Anyway, the standard is really, really vast and really, really deep. But that wasn't enough for the developers that write these awesome terminals. No, they wanted more features. It's not enough. So they created something called proprietary escape codes that are the things that makes this. Like all these pop-ups and things and fancy stuff and cool backgrounds, that's what they do. And even the twirly thing in how much time something took in PowerShell. Some implementations weren't that smart, though. I mean, it's probably a really, really bad idea to allow an escape sequence to run a command with arguments whenever somebody interacted it. But luckily enough, just as any other really, really bad idea, that's been solved since long. And it's really rare to find those. So I figured that, OK, that's cool, but I really needed something that was well-adapted, trusted, and people thought was really nice. So we can weaponize. Because we are nothing but tricksy hobbitses. That's who we are. And I found this really interesting one called OSC8. And if you ever run PowerShell and you messed it up, you'll get this error coming out with a link that you can click, and eventually they're going to tell you, turn you to get to this knowledge base page, right? And this is the ANSI escape sequence that you put in. So it starts with you defining it, OSC8, path that you want to get up to, and there's a link, and you can click that. The good people, and in the beginning, you were only allowed to use URIs like HTTP and HTTPS. But the fine people over at Windows Terminal thought that it was a really, really good idea to be able to use other things too. So they added the file path to it. And I'm cool with that, but I wonder what happens if you run that and click the link when you put command in there. There's a big chance that you can actually run stuff. Although, this is limited to only running one command and no parameters. But after the talk I did in DEF CON, a dude came up to me and said, yeah, no bypass for that. You can run Java, and it's going to allow you to do all the parameters. So here you are, click a link, and it's all fun. But to weaponize this in a cool way, what you can do, as you can see here, if we're not terminating it correctly, like we're not closing it off, what's going to happen is that this end output, all of this is going to turn to one big link. And even though some applications will give you a warning, like this one here, others don't. And I think it was really, really interesting, because I figured that, OK, that's cool. What happens if we curl that one and send it into our Docker application? Well, then suddenly, out of nowhere, everything turns into one big log. And you can actually just click around on all these things, and fun stuff will happen. Because some systems will add protections toward it, others won't. And I figured that, OK, what can we do with this? Well, we can do some nice tracking. So SSH is a protocol that's, by default on Mac, opens up terminal.app. So if we save that into a log file, an OOB log, have a link, and we click that, and it opens SSH, it automatically is going to pop terminal for you, and then you have a DNS ping back. That's perfect if you want to know somebody fiddled around with the file, right? Good stuff. And another way to get a really cool ping back too is to simply use this one here. Because if let's say that you're working inside a terminal, and you want to open up a new tab, and you want to be in the same directory that you were, they're using this sequence here, OSC7, to define the current working directory. So what happens if we run that, and you just look at this safe log file, what's going to happen is that it's going to give you a DNS ping back. And you didn't see anything of that happening. So it's perfect if you want to do some red teaming, and you want to know if somebody of the forensics team is poking around at your stuff. Pingbacks are cool. But that kind of wasn't enough for the fine people over at the developers. Because, text files are cool, but that's not enough. So we're going to add inline text support, inline image support inside these log files. In the latest version of VS Code's terminal, you now have the possibility to add images. And I'm like, I wonder, that's really interesting. I wonder what's inside this log file here. Because it's supporting an image format called sixel, which means that it's going to convert whatever pixel you put in into an image. How many of you want me to open this file and see what's in it? Oh, yeah. That's cool. All right. It's not the file you thought it was. Shame on you. But it's a cool thing. And you just imagine how interesting it is to probably put things inside other people's logs files. That's fun. OC52 is another one too, because if you ever use tmux or connected to a screen or whatever, you want to copy from your local buffer to another server's buffer and copy paste, is using OC52. And the thing that this is built around is you have this escape sequence. We start with OC52. We want to put that inside our clipboard, and then it's a base 64 string of whatever thing that we want to run. In this case, we say, okay, I want to open a calculator and then end with a new line. And if we do that in CSH, what's going to happen is going to add a new line, but it's not going to do anything more. You need to socially engineer that to happen. But it's going to pop calc for you. And the same thing goes with bash. But bash, on the other hand, does honor new lines. So all it takes for you is to accidentally cat the file and then paste, and it's going to pop calc for you, which is great. So I figured that's cool. That's really, really interesting. But how can I take this and do that as a vulnerable way? So I figured, okay, I'm just going to put that in a place where people can figure out that it's going to be annoying. So if we run that inside Docker terminal, it's going to do a certain warning. Or inside VS Code. It's going to warn you, like, are you sure you want to paste your clipboard? But most terminals don't. So there's a big chance that whatever you had in your terminal, it's just going to execute whenever you do it. And as you can see, the last one, the Windows one, had this really nice warning where if you have all these lines coming in there, it's going to pop up and it's going to say, warning, there's going to be a clipboard thing coming in. But if we add shitloads of spaces or enters before it, it's going to be empty. And I know you don't read ULEAs and all that stuff anyway. So you're just going to say, OK, and click it, and then smash good stuff's going to happen. Because that's kind of what we want to do. And I figured that's cool, but I wanted to create like a payload that would work on all systems. So hey, why don't you an XXS, Unix, Linux kind of polyglot clipboard payload thingy, where we'll take this JavaScript, and then we'll do a curl command, and then we'll do some PowerShell magic, base 64 that into a beautiful string and put it in bad log. Well, why not? And now we're running it, and all these different kind of systems, it acts kind of differently. Some will do warnings, others will not. And when I'm running it, I'm catting it, then I'm just pasting it. And you can see that it's running all these commands, and eventually if you put it in a browser, it's going to pop that. And you get all these pingbacks coming in where they'll support the variables that you put in, like hostname and whatever. Because you're putting inside the clipboard of the user in user space. So if the user is tailing a log and that one comes in and doing something else, and then you just copies a string, copies it, and then pastes it somewhere to do the normal work. But in the back end, they're tailing this log. It's going to populate their clipboard, and accidentally they paste it somewhere, and this polyglot is going to fire. That requires user to interact with it. And of course, you can do other exfiltration styles like reading local files or whatever. The creativity here is all about up to you. Getting reverse shells, obviously. But even though that's cool, that's going to require users to do something. So I figured that another way that we can interact with log files and mess things up for the forensic people is to, we hide our tracks and we mess things up. And a really easy way to hide our tracks is to just do different positions inside the screen where we'll move the cursor all the way up to the top, or just clear whatever buffer we had. It's going to show this here by showing you this list of sequences of things, and in the end, I'm going to do the age thing, and it clears, it goes up again. So imagine that you're going through a log file, like this one here. You have this log file that's running, and you're sending that one in. It's going to clear the log for you. And it doesn't matter what you do. If you go back and do something else, what it's going to do is going to read to that certain point, and find it, and it clears shit for you again. So it's a very easy way to just disrupt log output and make it really hard for those developers and forensic people. I know this is somewhat annoying, but if we want to get really annoying, let's just DOS and brick stuff. Because why not? And I found a really useful way to do this. And most of these things that I'm showing you are not proprietary things. These are the standard. I'm just using it in a very mischievous way. And one would be to print stuff. Because if you're running this print thing here, what's going to happen is that it's going to show you a print job. And that's okay, but imagine you getting 4,000 of those. That's going to be a bit annoying. But you can also do, like in the back in the days, we all have these matrix printers. Like next to your cool data center, you have this physical printer that will like writing the log files out. If we, in this case, say we want to send the output to 5i, which is send it out to whatever printer thing, it's going to break the terminal. There's no data coming out because it's being sent in the background, but you can't see shit. It's perfect if you want to make sure that somebody just has to close their terminal or start over again. And that is somewhat really annoying. But if we want to even more annoying, we can use something called mouse tracking. And if you ever use like some kind of old school Linux system where you do install and it's going to a pop-up window comes up and you need to press OK because there's some kernel update, whatever, that's tracking where you are using the mouse. And we can just take all these parameters that asks where it's going to go and send those in. And what's going to happen is whatever you move your cursor, that's going to get printed out. And if you accidentally get too much of there, it's going to run whatever commands. Interesting. Imagine combining these, putting a payload on the command line, and then just messing mouses up because people's going to be, it's not working, I'm going to push all the buttons, and things just fire. Nice. And then we have this. It's beautiful because what it does is that whatever character you have, the preceding character repeated X amount of times. And this is perfect if you want to measure how wide the screen are. That's perfect. But what happens if we do like this, like peace sign emoji, let's say we're going to do it 10 times, it's going to give us 10 emojis coming in. That's cool. But how about putting in 1 billion of these? Well, there's going to be 1 billion of those rendered. And since it's just not one character, Unicode is 5. You get shitloads of things being processed inside whatever turbo you do. And bear with me, do not run this in production because this is by design. You can't kind of fix it, and it's going to break stuff because what it's going to do is it's going to put all things there, and whenever you touch that container, Docker, whatever, it's going to kill it because it's not going to be able to render it, and it dies. And all these applications here, they died. And even in the thing that I had on my phone, and I run it there, it just crashed and died. Things that crash and die might just lead to overflows. Interesting attack vector. And I know for certain that there are now overflows because I had conversations with researchers after my talk that successfully now have found really cool stuff where this kind of memory overload thing breaks. New attack vector, fun times. And all it takes is this tiny string. So imagine for a second that you decided to put these inside the server version on someone. And all these farm scanner boys were just farming the internet, but what they're getting back is 10 million kind of this. So when they're trying to go through their stuff, it's just going to kill it. Good stuff, right? And because what happens when you curl it is that it's going to render. And whatever log file you do, HTTP, HTTPX, whatever, all those things do that because they don't sanitize it. Okay, you got a question? Scary-looking serial kind of kid? Yeah, I know. I haven't found an RC. All these shenanigans and cool stuff, but we talked about arbitrary code injection. I didn't find any of those, so I know it's weak. And these are actually really sad times, and I couldn't get any further because I'm really, really sad. And darkness just hit me, but then light came in the shape and form of David Leadbeater and his talk, Houdini in the Terminal, that he did at Blue Hat, because he did not focus on the things that I did, the shenanigans. No, he went for RCEs, and he didn't find one. He found 6 of them, and he even now found a bunch of more after that. And the cool thing is that he found out a way where he can use device control and request status strings. I know that's a mouthful, to create cool stuff. And he created this GitHub repo for it, and then got a bunch of really nice CVs in Kube and whatever. And the Gillstrand boys, they thought that was sweet. So I reached out to him and asked him about his research, and I started to figure out how, because he was running that locally. And I'm like, I want to be able to see if I'm able to smuggle this into a log file and see how it breaks. And so I figured out that if I URL encode it this way and create this kind of thing, what it's going to do is actually this. We'll have this new lines coming in, then it's going to do the escape injection, and then things are just going to go happy. So if we're having the earlier version of item 2, which is now updated, that got RC'd again, so it's updated twice now. So we're now currently on a state where it's broken. If we run that in here, and you can see I'm running these things, then I decide to put that thing inside the path here. What's going to happen is that we smash it, boom, it pops cat, which is great. And the user didn't do anything. Yes, we applaud for that. Yoo-hoo! And I know. The reason why this even works is because we're using item 2, which is vulnerable to this. And it used to be vulnerable for something called this sequence introducer here. Because what's so beautiful with this is that he started out with realizing that what he'll do here is that he wanted to report back Control-C. So escape out of whatever kind of application you're running. So if you're running Docker attach, it's going to kill your Docker container because it just escapes out of it. And then he decides to put open calculator in a new line on the command line, and then just smash in, and then nothing more. Because what it does is that this $CP$QM, what that does is that it asks you, what kind of color is my terminal currently using? But since we're adding all this other stuff in there, we're populating it. So when we're sending the information back, it's going to relay the things that we already put in there, which is the Control-C, the enter, and the open command, resulting in putting this here, and then we're getting whatever arbitrary command injection that we wanted. And David's research for me was like the Mike Metzger moment in BMX, because before he did a backflip in competition, it was impossible. But if you're not doing it today, like a double backflip, can, whoosh, you suck. But that was my moment when I realized, you can do it that way. So I started to look at Kitty, which is another terminal. And they had this really nice thing called OSC 5113, which is a file transfer over TTY functionality. And it took a lot of inputs. And I realized the test input reflected back. So what happens if we replace whatever is inside there with a new line, open calculator, and send it away? Well, inside Kitty, what it's going to do is that you're going to start this thing, and it's going to give you a question that says, does the remote machine have some files to send to you? Would you like to do that? And you say no, and it just pops calc for you. But I hear you thinking like, yeah, but if you say yes, what happens then? Well, it's actually the same kind of thing, because it gives you the question, it's going to pop it for you anyway. So there's no way getting out of that one, which is beautiful. And the Beatles boys, they freaking love that. Boom. I'm like, yeah. Pretty badass, actually, to be honest. And I just started poking around on it, because that was the first thing I poked at, and I realized, got another shell, fun. And other things that are more sneaky but can generate the same kind of thing is that if you ever use VS Code, it has this shell integration feature called OC633. And it's the thing that does this. The blue dots, when you're doing things, and you can right-click those, and you can move around in the code like markers, but if you right-click it, it's going to define, like, this is a start point, this is another thing, and all these things. I'm like, that's cool. But it has this last one here, explicitly set the command line, because the idea is that you don't want any other kind of data than the one that you want in there, but it's going to treat it really nice. So why not just set that one and see what happens? Because if we cat this safe log, it's all good. And we right-click it, run the command again. It's going to give you this warning here. And it's going to execute the command. And the reason why you saw here in the beginning that you couldn't see the whole kind of output is because the limit to show any output is 254 characters. Add 256 in there, it's just going to go, OK, whatever. You want to run this? and this is what's going to come out. The user didn't see anything of this. This is just sneaky stuff. And to answer the question, like, is it possible to execute commands inside a user's terminal? Well, the answer is yes for that. But whose fault is it that it actually is possible to do it? And this is like a conversation that is going on forever, because there's going to be all these web app developers that say, no, it's a terminal user's fault. And then the terminal people says like, yeah, but we need to customize shit. And then you use the DevOps people and say, if you're going to remove their cool background, they're going to go, no, no happy, no. So even though I can hear you, old school dev guy in the back, maybe you're sitting there and you're just ranting for yourself, but everybody with a name knows that you can't use cat a file or click on any email links. But that's actually not true, because we need to protect our users, because most users that interact with this are shell users, and those are usually privileged users. And the only way to protect them is to sanitize the input and escape the output. And if we don't do that, there's going to be consequences. And if you feel like trying this for yourself, I created this POC site called evil.terminalinjection.com. That it just contains shitloads of different escape sequences that are non-malicious, but going to create shenanigans use stuff. So if you, let's say that you're curling this one and you save it into bad log, what's going to happen is that you're going to smash all these different kind of things. This is an iTerm, you're going to pop a calc there, and then you're going to brick whatever output that you're using. This one has a warning for the clipboard injection, though. And if you do the same thing in terminal app, it's not going to do all the other stuff. It's just going to brick whatever output and just report things. So that's going to be ruined for you. And if you use a Windows 11 vanilla one that hasn't been updated, that's just going to die. So yeah, it's interesting. And this is a work in progress. I'm just adding more stuff there as I go. I'm new into this research field, and it's fun. But if you want to do some black box testing and look for some cool stuff, you should always go for the 400 or 500 errors, because access logs are usually very well sanitized, but error output files aren't. They're very verbose in their output. And if you're troubleshooting something as a high-privileged user, are you going to go to the access log? Yeah, probably. But if you really want to dig into it, you're going to be in the error log. So the debug logs and all those stuff there, all these errors get put in. And those are usually generated by 500 errors. So one way that I found that this is really interesting is that you have these normal like post requests coming in, and it's going to be some key, some kind of value JSON stuff. If we add Unicode after this one with a new line and other stuff and send that in, and if it comes back with an internal server error, or you get this error which says, this query does not support reflecting the kind of data coming back, and it's not slashed, like this one here is escaped, this one is not. You see the extra slash coming in? That is a really high indicator that if you grep or cat or play with that log, things are going to fire. And you have also, but sometimes, you know, they escape it real good because they realize it's going to be Unicode. But then you can send in it raw format, like hex. And since escape sequences are invisible characters, and some of the characters that we're using here, like these parentheses kind of thingies or brackets, they aren't being seen as malicious. They will get entered. So what this actually does is, it's the 1B here, which is the escape sequence. And once again, it's going to get back the first one, but now it's formally put without the slash. So you're bypassing the filter here. And bear with me, there's a lot of chances for false positives here, because sometimes developers like just to strip whatever output they have. You can't see it, but it's still going to end up in the logs. So it's tricky. And sometimes you'll get errors like this when there's no data coming back in the response. But as we saw in the beginning, we're sending this 400 error, but it still got logged as is an issue inside the log file. And in this case, I mean, 400 errors, a little bit gray zone, because normally those don't get logged, but it's a good indicator to keep on fussing so you can break it and get those 500 error. And to be real honest, during my research, I would say this is everywhere. It's all over. And I did some work with Splunk, and I recently got allowed to speak about some of the CVEs that came out of that adventure. And they fixed all their stuff, and big fucking love to their team for caring about log files for real. Some other companies don't do that. You have to figure out which ones they are. And before you start creating your nuclei templates like this and go brrr, hoping to get this, you need to remember that you need access to log files to actually verify that this happened or not. So getting local Dockers installed and certain things to look at them is a good indicator before you go throwing stuff away. So let's do a quick recap on that. People tend to forget. The old is the new, and this is new research, and it's way more things to come here. And to be honest, this thing is everywhere, because even when I was writing this nuclei template, it fired inside there too. So they're not escaping it properly. And you kind of should remember that even though something in the beginning feels like it's very meh, today, that can turn into, oh crap. Because it all boils down to creativity. The person that looks at this just needs to think outside the box a bit. And getting back to the original answer, like your log files, do you still trust them? Hi, I'm STÖK, and at STÖK on all platforms, and thank you for attending my talk.